Are you ready to explore the intersection of science and entrepreneurship in the world of geospatial data? Welcome to the Venture Out events, Bridging Science and Entrepreneurship in Geospatial Data with Planet. My name is Megan Steele, Innovation Ecosystem Engagement for the Accelerate for Impact platform of the CGIAR, the team bringing you this event. The Accelerate for Impact platform is a venture space that builds on CGIAR's legacy of research and innovation to co-design, accelerate, and fund science-based innovations to address some of the world's most pressing challenges at the nexus of agriculture, environment, and health. At the Accelerate for Impact platform, we adopt innovative partnership models to bridge research products from lab to market, creating demand for CGIAR science and connecting it with the agri-food and climate tech innovation ecosystem. Today, we convene scientists and innovators across the CGIAR, as well as the wider innovation ecosystem. This event not only will promote learning and inspiration, but also aims to facilitate participation in an interactive discussion exploring synergies for the power of using satellite data for sustainable agriculture and climate action. Our event today is dedicated to explore the successful story of Planet, a public benefit corporation driven by a mission to image all of Earth's landmass every day and make global change visible, accessible, and actionable. Over the past decade, Planet has revolutionized the Earth observation industry, democratizing access to satellite data beyond the traditional sectors. To that end, Planet provides the leading web geo platform with the highest frequency satellite data available and foundational analytics to derive insights, empowering users across the world to make impactful and timely decisions. We are here to learn more about Planet as they showcase their cutting-edge innovations and success stories in the field. We want to trigger scientists' interest to learn and explore new pathways to apply satellite data in innovative ways, to produce research with the potential to transform food systems and accelerate the sustainable development goals. Joining us are agriculture specialists from Planet, Misty Tucker and Kinsie Rayburn. Later on, we will welcome CGIAR experts in this subject area, Jawoo Koo, Aniruddha Ghosh, Reymondin, and Wendy Francesconi to join the panel for a Q&A discussion. We'll begin with a demonstration of the work Planet is doing at the cutting edge of Earth observation data. Then don't miss the opportunity to participate in a discussion with Planet, CGIAR experts, and the audience by submitting questions and your reflections to the Zoom Q&A feature. Without further ado, I'd like to welcome Misty Tucker and Kinsie Rayburn, agriculture specialists from Planet.
Thank you very much for the intro, Megan. Hello, everyone. My name is Kinsie Rayburn. As Megan was introducing us, I'm going to go ahead and share my screen and get the presentation started. And then we will get some introductions in. So today we're going to be talking about bridging science and entrepreneurship in geospatial data with Planet. You'll be hearing from myself. So I serve in the role as customer success manager for agriculture at Planet. And my background is in agricultural engineering, conservation agriculture, and the human dimensions of change on the farm. So as anybody who's worked with any land managers out there, we do know that it's not the acres themselves that make decisions, but the managers on that land that are using the best information and resources available to help them make their decisions. And then if Misty as well, and give herself a bit of an introduction, and then we'll get started.
Hello, everyone. My name is Misty Tucker, and I am the Global Industry Principal for Planet for Agriculture. My original vocation was as an agronomist. I spent about 10 years in marker-assisted disease resistance plant breeding, and then I transitioned to field agronomy, and then ultimately to precision agriculture, which is how I found my way to Planet. And it's a pleasure to speak with you all today.
Thank you, Misty. So we'll go ahead and jump right in, give you an idea what we're going to talk about. We'll do a brief overview of Planet in agriculture, some crop monitoring use cases, look at forest and pasture, and then some current research and innovation, and then hand it over for questions and answers with the rest of the panelists. So as Megan was saying, Planet's mission is to image the whole world every day, making change visible, accessible, and actionable. And this has been our unchanging mission since 2010. To give you a little bit of an idea of how the satellites that we operate how they are kind of located in space and the job that they do is we have two different sets of satellites. One is our Planet Doves, and those are in a sun-synchronous orbit around the globe, imaging the entire world every day for a near daily cadence. And then we also have our Planet SkySat satellites, which are higher resolution at the 50 centimeters, as opposed to the 3.7 meter resolution for Planet Doves. And those are the satellites that you can move through space to your exact AOI of what you're interested in and what you're trying to investigate. With the combination of these two flocks of satellites that we do have, we have excellent coverage, we have high cadence, we have high resolution, and therefore you can see whatever's changing on the ground, so that intervention or mitigation, prevention, all those things can come into play. And then we need to go to the next slide. Planet's approach has also been that, historically in satellite data, we're looking at low revisit rates, kind of limited coverage, inefficient access, and tasking minimums. The way that Planet has organized the satellites in space that orbit the Earth are that we get a higher frequency, we get complete imaging, and we have a simple API access. As I said in the beginning, my background's in agricultural engineering, so APIs are not my area of expertise, but given that I've come in and learned them, I can agree that the simple part of that API access is true. And then we also have the daily collections on your field. Whereas Planet might be a global company, we have a lot of customers that really focus on specific AOIs in specific regions, and we support that fully so that customers can still get everything that they need, and while we're helping them meet the needs that they have for their projects. Whenever we're talking about cadence and resolution, this is an example of how much of coverage that we get compared to some of the other satellite fleets that are out there. So in the images that you're seeing here is a calendar of Landsat and Sentinel-2 for July 2021, as well as a 30-meter spatial resolution, just kind of showing you how much could be captured over that time and then what the end result of that imagery looks like. And then Planet, between PlanetScope and SkySat, we can fill a much higher cadence. We can't move clouds, not that anybody would want to, that might be a disaster. But we can capture the images. And the good thing about working in land use and agriculture is that there's still useful information between the clouds that we can work with. And then our PlanetScope resolution being at 3.7 meters also gives you the opportunity to have a visual analysis of what you're looking at, so that you can do remote sensing indices equations on top of that imagery, but you can still do a visual analysis if you just want to look at something quickly. This slide, I'm going to build on a little bit more later, but we do have archive that goes back to 2017, as well as future monitoring. So this is a really good use case for how to build models for change detection, is going back to 2017, realizing what was happening on the ground and the characteristics of that land at the time, and then forward filling that with future imagery so that you can address the change that's happening after you've categorized it and found evidence that there is change. Like I said, I'll expand on this a little bit more when we get to our examples. We also have 8 spectral bands for the new SuperDove fleet. So we've added coastal blue, another green, another yellow, and red edge to give more flexibility in what indices can be calculated using Planet imagery, therefore providing deeper insights over the land, the forest, whatever crops are of interest to the researcher, to the project, to the organization, or anybody working with Planet. Our APIs, like I said, they are very useful, very simple, but we've also improved it so you can do more band calculations within the API, so you can pull in derivatives instead of pulling in an image and then working with them. So trying to make the process and the workflow for all imagery pipeline needs as seamless, as smooth as we possibly can. And we've also simplified the entire catalog. So whenever you do look for imagery, you're getting the best, clearest imagery that meets your criteria every time that you're looking for it, and then ordering that to do your work with. So like I said, I wanted to start off with a little bit of background just on Planet to set the stage, and then I'll hand it over to Misty for crop monitoring use cases. And then you'll hear from me again whenever she's done with this on some forest and pastures. So Misty, take it away.
Thank you, Kinsie. So moving right into crop monitoring use cases. Next slide. So when we're talking about remote sensing in agriculture, most of the use cases that many of you are probably familiar with are what I would call the traditional use cases for satellite imagery. This is when we're taking a single raster layer from remote sensing data and using it to derive insights into what's happening within field. Oftentimes, we use this single raster layer to create management zones for variable rate prescriptions or for field monitoring and directed scouting. Here you can see an example of a variable rate application prescription. You can also see a field that is one that I personally scouted myself, where I was using remote sensing data to guide my actions within field. Next slide. One of the things that is, I guess I would call it less well known and less capitalized upon with the traditional use cases for remote sensing data, is the use of different indexes to derive different types of insights. Oftentimes, NDVI is the index that is most commonly used in order to derive insights for agricultural applications. However, NDVI has some limitations, especially when it comes to mid-season to late season. Therefore, I would recommend managing your indexes by varying indices throughout the season. For example, early season, there is a fair amount of soil reflectance that creates noise within remote sensing imagery. Using an index like the Soil Adjusted Vegetation Index optimizes the remote sensing data value at that phenological stage. Mid-season, NDVI still does a very good job for most use cases. And then late season, NDVI tends to wash out or become saturated. And therefore, switching from an index like NDVI to NDRE, or normalized difference red edge index, allows greater penetration into the canopy and therefore greater insights into what's happening within the field. Next. And directly speaking to this, this is an excellent example of the red edge band being used in place of the reg band in order to derive further insights into what's occurring within a field. One of the more unique indices is the nitrogen nutrition index, and this can be used to monitor the crop nutrition for a given crop based upon a critical nitrogen dilution curve that can be developed and is incredibly region specific. Next. So this particular use case is one that I observed while I was looking for other data within the field. It's a situation where there was an equipment failure every time the tractor turned around within this field. The lay-by application of nutrition started at 0 and then eventually ramped up to 100. So you can see that gradient from yellow to green throughout the field based upon this misapplication of nutrition. And Kinsie, if you want to hit the link, it should go to.
Are you seeing the video?
Yes, no sound.
Well, since it's you, I feel like we can probably cover that one. So since the video is already going to be you.
So I apologize that we're not having sound right now. So basically the video walks you through a situation where on the left-hand side, you can see the NDVI for that field. You almost can't see any type of variation within the field, and this is due to saturation. So the red band doesn't penetrate very far into the canopy of a crop, and therefore this creates this saturated situation. This situation that you can see on the right side clearly shows that checkerboard pattern throughout the field that when you're looking down on the field from above, you can very clearly see. And so therefore, this is a really great example of how varying your indices throughout the season based upon the crop's phenological stage and the limitations of the index that you're working with can gain you more insights into what's actually happening in field. Next. And I will hand it back to Kinsie for some use cases in forests and pasture.
Thank you, Misty. So whenever we're thinking about forest and pasture use cases, I wanted to start with a couple different examples. So we have a commercial example, we have more research, we have monitoring, and we have interventions. This first example is from Organic Valley. They are an organic dairy production commercial operation out of the United States. And we work with them and their farmers to implement rotational grazing practices that are driven by that are data-driven insights. So what we're looking at here is NDVI versus NDRE over one of the fields for one of the growers for Organic Valley. And we started with NDVI, but as Misty's been talking about, we were seeing a lot less granular insights based on that. And then whenever we had the upgrade to 8 spectral bands, we did a regression analysis to decide which of the indices are going to be best suited for rotational grazing recommendations on the ground. And NDRE comes out on top as the most highly accurate to give us biomass estimations in the area. And so what we're looking at here is October 10th, 2022 with NDVI and NDRE on the right side of the screen. And then what Organic Valley does beyond that is they go and color grade the actual paddocks to make recommendations based on it, as well as a graph. Because sometimes whenever you're managing in the field, something could look a lot more lush than it is. And the worst thing you're going to want in permanent ground cover and rotational grazing is if you lose your rootstock or if mud is introduced into the scenario, because then you have to have an intervention. And so Organic Valley works with their customers and sends them reports that look very similar to this to help them navigate which paddock is the best place to have your rotational grazing. This is also very useful for carbon programs and permanent pastures, because then you can have evidence that you are complying with the different programs that are available, and understanding where you need to put your cattle, any programs that you are in compliance with, and then making recommendations beyond the visible using the graph so that you can go to the right place based on how much biomass is available. The next step in work like this is going beyond biomass availability and looking at biomass quality. So what is the available biomass in the field? What is the nutritional quality of that? And so, so land managers can move the cattle around looking beyond just how much is available to be eaten, but what good is that going to do once it's consumed by the cattle? This other example is a video from for deforestation in Vietnam. And what this is really showing, that this is one of the use cases where it wasn't necessarily that there was law enforcement involved. This group was really looking for evidence that policy intervention was necessary. So you can see how the expansion of the deforestation is happening over this area between 2009 and 2016. But it's evidence like this that needs to be taken to policymakers for that intervention, or to, you know, rally the troops around whatever law enforcement is going to be, whether you're monitoring legal or illegal activities. Just to get an idea of where you need to go, how fast you need to get there, what is the damage already, and creating a benchmark for what is acceptable versus unacceptable. And now it wants to stay on this one. We already watched this video. Here we go. And this is another example. This is a manual intervention for sugarcane in the Amazon. So what happened in this occasion was we had a group come in and they went through our archive data I was talking about later with the larger stack and the smaller stack of the imagery that was available. And whenever they were downloading and pulling in the orders for the archive imagery, they were doing a manual analysis over this area. So between June and January, you're seeing, you know, gross amounts of expansion into the Amazon rainforest beyond what this organization was supposed to be doing. And while they couldn't go in and intervene immediately, what they needed was the evidence. They needed unequivocal evidence that change had happened on the ground and that there was an issue that needed to be resolved. Well, and then if you go and start to imagine the total coverage of the Amazon forest, or you're looking at all cropland all over the world, you really can't do this at a manual level if you want to look at large regional areas. And so the kind of the next idea that we're working with and customers found success with is scaling that manual analysis to nationwide solutions. And what you're seeing now is kind of a framework of how to do that with Planet imagery. So you're creating the orders that you have for your subscription. The subscriptions allow you to continuously monitor an AOI within whatever time frame that you're interested in. So if it goes into the past, you're going to get all the imagery over that AOI for the entirety of the time of interest that you have. And then you're also going to set a forward-looking subscription so that you get continuous imagery that's coming in. And customers are building models based on this for change detection through the archive imagery for faster intervention and faster collection of evidence for change. And some examples of this, one of the biggest is the National Forest Monitoring. Planet and Norway's International Climate Forest Initiative, NICFI, have created a partnership where NICFI users can access Planet high-resolution analysis-ready mosaics. And I wanted to provide some examples of this as well. So in the Democratic Republic of the Congo, they're doing greenhouse gas emission inventories, which is going to help create a benchmark to act upon. Same thing that they're happening with monitoring and intervention in the lower Mekong in Thailand and Vietnam. So building that national capacity for preventative illegal activities, but also compliance and legal activities. So in Vietnam and Thailand, they're using the insights that they're gleaning from Planet imagery to have active on-the-ground intervention into illegal activities. And then also benchmarking in Peru that there's the RED Plus activities that go on. And every time that funding is attached with something, everybody wants to know that it's going well, how it's going, if it's successful. And that means if it is successful and you can prove it, that gives you more validity to move into the future and continue that same kind of research. And that's what they're doing in Peru, and it's proven very successful. If you'd like to learn more about it, if you go to planet.com/NICFI, you can see a lot more of the use cases, some of the research studies, and just kind of look in closer to what's happening under that program. And it is very, very impactful and very, very influential. This is one of the examples that we're looking at for mining in Ecuador. So this is, scaling from that individual sugarcane in the Amazon use case to more of an automated, where in this scenario, what customers did is they downloaded that archive imagery, built a change detection model on top of it that automatically triggers a higher resolution satellite to go and capture imagery over the area that they're interested in. So you can see through these white boxes that there has been large changes that are both visibly noticeable, and the algorithms are picking them up. So in the first block here, you're kind of seeing, yes, it's a little bit of a dig out, but it's not that extensive. In the second image, it's getting more extensive, and the third again. And then in the fourth one, this is the resolution that you can look at to see the excavators that are happening on the ground, how far the extension has been. And this was an automatic alert and tipping queue system where it allowed these organizations to scale more quickly because they didn't have to have one person paying attention to what was happening in the images and doing a manual analysis. It was more of the algorithms behind it, and then the automatic triggering of a SkySat satellite that allowed them to look at larger areas, larger projects that are going on, and expand their reach through automation. And then what I think is one of the more exciting parts will be the current research and innovation that Misty will wrap up our presentation with, and then we'll jump into questions and answers. Back to
Thank you, Kinsie. Next. So some of the current research and innovation utilizing PlanetScope data within the 2022 year. One of the ones that I thought was really compelling was this particular study that uses a harmonized collection of high resolution planet data, Sentinel-2, Landsat-8, and additional coarser resolution imagery from MODIS to examine a multi-satellite data fusion and machine learning approach to deliver a radiometrically calibrated and gap field time series of daily leaf area index. This was able to deliver the LAI, or leaf area index, at an unprecedented spatial resolution of 3 meters. And the data demonstrated a clear capacity to reproduce key crop development stages and growth patterns from initial planting to maturity and ultimately harvest. Next. So this particular study is examining cropland mapping in smallholder landscapes. And when looking and examining cropland mapping in smallholder landscapes, it's particularly challenging because it's very complex and there are fragmented landscapes as well as labor intensive and unmechanized land management. This leads to high within field variability, rapid dynamics shifting, and substantial proportions of short-term fallows. To overcome these challenges, this study presented a large area mapping framework that identified active cropland and short-term fallows in smallholder landscapes for the 2020-2021 growing season. All of this was done at a PlanetScope resolution. This study focused on northern Mozambique, an area comprising 381,698 square kilometers. And this approach was based on PlanetScope mosaics made openly available through Norway's International Climate and Forest Initiative, or NICFI, as Kinsie has previously alluded to. The multi-temporal co-registration of the PlanetScope data using seasonal Sentinel-2 based images and derived consistent gap-free seasonal time series metrics. These were employed to classify the active cropland and the short-term fallows. The map from this study was accurate, with the main error type being the commission of active cropland. And here on the slide, you can see the 3 fields that were utilized for this study. 2 of them were irrigated and 1 was dry land. The dry land field is the square one. And you can very clearly see some of the differences that were observed in the leaf area index based upon the type of irrigation that was made available to the crop. On the right side, you can see the way the data flowed through their system as they processed it in order to derive the daily LAI. Next. Okay. So this particular study is about cropland mapping and smallholder agriculture. And the individuals who executed this study developed an approach designed to address 2 main problems. These, in order to map Ghana's croplands, they overcame the spatiotemporal mismatch that often happens with remote sensing data, and they converted daily high-resolution imagery from Planet into cloud-free composites, one being the primary growing season and the second being the subsequent dry season, covering the 2018 agricultural year all the way to 2020, this provided a seasonal contrast that helped to improve the classification accuracy. To address the problem of label availability, they created a platform that assessed and minimized label error. They also utilized and iteratively trained a random forest classifier, which identified the most informative training sample based on prediction uncertainty. And here you can see the contrast between what was made available previously with the generic land cover maps, and then cropland specific maps, as well as maps that were derived utilizing Planet data while compensating for the 2 main issues that remote sensing data has posed for this type of classification. Next. So this particular study looks at smallholder dominated croplands and how we examine those at national scale. Mapping the characteristics of Africa's smallholder dominated croplands, including the size and number of fields, can provide critical insights into food security and a range of other socioeconomic and environmental concerns. This particular study was examining how many fields and what size of fields we were working with within smallholder agriculture. Next. Ultimately, the estimates from this particular study were able to demonstrate that the distribution of croplands in Ghana next one. Nope. Thank you. Ultimately, the estimates from this study showed that the typical field size in Ghana was about 1.73 hectares, ranging from 0.96 hectares in AOI 13 to 2.82 hectares in AOI 4, with fields in the forest zone AOIs generally smaller than those in the northern half of the country. The estimated total number of fields is 1,662,281, or 205 fields per tile grid. This varied from 108 fields per tile in AOI 4 to 399 in AOI 6. Next. So that concludes the section on more current studies and use cases for PlanetScope imagery. And we will turn to the Q&A and questions panel.
Thank you so much, Misty and Kinsie, for that fantastic presentation. There's certainly so much exciting work being done by Planet, especially those use cases toward the end. So I cannot wait to dive in. Now I'm thrilled to invite 4 experts from CGIAR to guide our Q&A discussion. And again, we want to make sure that you as the audience get the most out of this event. So please don't hesitate to ask questions or pose interesting topics using the Zoom webinar Q&A function. Our panelists and speakers are here not only to explore their ideas, but also to spotlight some of yours. So take advantage of this opportunity to contribute, and let's get into it. Welcome, Jawoo Koo, Aniruddha Ghosh, Reymondin, and Wendy Francesconi. Let's kick it off by hearing your reflections on the potential that's been presented today. Welcome, panelists.
Okay, great. Yeah, thanks, Megan. Let me go ahead. Thanks a lot for this presentation. It's so exciting to see a lot of innovative use cases, as well as more strengthened kind of traditional use cases, kind of empowered to do better mapping, better higher frequency, and more detailed. This is so exciting time. I just wanted to quickly describe what kind of use cases we have in CGIAR using Planet's like very high temporal, high spatial temporal resolutions satellite data. A few months ago, we did a survey across our researchers in CGIAR, what kind of use cases we already have or we want to have once we have this kind of data accessible. There are lots of kind of similarity of what we do already covered in the presentation. For example, real-time mapping of agricultural geography, like crop type mapping, growth and yield estimate. And this is quite encouraging area because, yeah, I mean, this LAI, leaf area index mapping just using satellite, this will open up quite a lot of possibilities. For example, we were just discussing the other day how we can strengthen or, amplify the LAI data collection on the ground, because this can be an input to crop growth model and different types of modeling activities we are doing. And then that calibrated model can be used to estimate yield growth and so many different applications. So this kind of additional data using satellite will open up lots of exciting possibilities. We use satellite data for a lot of natural resource management and ecosystem monitoring and mapping activities, land use and land cover, soil moisture and soil carbon monitoring, and deforestation, and water channel and water quality, and even river morphology change detections. Those are also quite highly relevant for CGIAR and at large scale of food, land, and water system monitoring research. And we also use this kind of opportunity of the high frequency data in analytics, detecting changes in soil and water conservation, especially infrastructure wide, like dams and different irrigation facilities, irrigation the equipment and how they are functioning and whether they are supplying water when it's needed or not. So that's also very much relevant. We use this kind of data for assessing flood impact, like a before and after flood, and to see how much like buildings are submerged and how much crops are lost and kind of thing, very critical. So out of that, we can profile climate risk in different areas and different types of disaster potentially. We also use this kind of data for tracking urbanization and mapping peri-urban agriculture to see how much food will be available for urban city centers and, for the country economy at large scale. Especially during the COVID, this was really important. So this kind of data kind of effectively replaced our need to monitor like a field level data, because we couldn't really get to the field whenever we needed to go. So we utilize this kind of data to replace or reduce the number of times, the number of visits that we needed to have in the field. So yeah, lots of exciting ideas here. I will let Ani and others follow and give more kind of ideas and add more discussion point. Thanks.
Yeah, I can talk about a couple of use cases for which we have been using Planet data for the last few years. One of them is the crop type mapping work in sub-Saharan Africa smallholder regions. So we have been using the Planet data for doing some cropland map in Tanzania. So one of the challenges that we faced there is basically the data provides a lot of information, and as CGIAR researchers and kind of the resources we often don't have access to, let's say, high-speed internet or that kind of computational resources to actually process the data. Because just to give you an example from a practical side, Jawoo gave overall ideas about different projects, but also when we are looking at the Planet data, one of the challenges we have to realize that it's unlike the data from MODIS, Landsat or Sentinel, because each day we can get at least 10 or so data coming from different satellites which have different calibration, which is different footprint, right? So they all need to be aligned, and then we need to analyze the data. Now, when we are working with this kind of high resolution data, we also have to figure out the challenge regarding the accuracy of the ground data, right? Often we don't have ground data which are that much accurate that we can use for training this kind of data. So yeah, but it was a wonderful experience to see, when we were missing most of the growing season, if we are only using MODIS or Sentinel or Landsat, while using Planet, we were able to get regular time stuff of imagery, so which was quite helpful in this case. The other use case we have been having with Planet is basically a new product that Planet started delivering after they acquired this company called Vandersat. So this is a soil moisture and biomass product. So we are using the soil moisture and biomass to derive insurance index. So basically, instead of using, for index insurance purposes, we just, historically it is used, for example, rainfall data, or for satellite signatures, it could be NDVI or some of the indices that was mentioned. But what we are using right now is a soil moisture-based index, which we think is a much better predictor for the crop growth, or even the biomass, which we think is a much direct predictor of the crop yield. So this project is being piloted in Kenya right now. So we are focusing on 4 crops and 10 counties, and we'll be sharing the results as soon as we get some promising output from this. So I will let our colleague Luis and Wendy share on their experiences.
Yeah, thank you very much, Annie, and all for the great presentation up to now. Yeah, something we are particularly interested in the field of research I particularly do is first in forestry and deforestation monitoring. Some example like you showed. We work a lot in the field and with different governments to monitor deforestation and to better understand the drivers of deforestation behind it. And we've already used Planet quite a bit in checking alerts ahead of time before we go to the field, or things like this, like when we have alerts of deforestation, something like that, to reduce the probability of going to the field and checking something that is not true or a false alerts. And we would like to use much more Planet in identifying what was the driver of deforestation without having to go to the field. Another, using the high resolution offered by the satellite. Another area of research that is particularly interesting for us is better characterizing different type of agroforestry. I'm particularly thinking about coffee systems or cocoa systems with different level of shade trees. We're trying to get as close as being able to count every shade trees in a given plot, something like that. So that's the end goal for the moment. We are more working on levels like a highly shaded, medium shaded, and that kind of things. But if we could get to one count every single trees, that would be absolutely great at landscape level. Of course, we're always quite interested at working at landscape level, so large areas, and not so much at individual plots when we are working on different projects. And yeah, in general, better understanding what leads to changes in the landscape using the high resolution imagery. I think it's where in my case we would particularly be interested in Planet's data. Yeah, thanks. Wendy, if you want to go next.
Thank you. Thanks for the presentation, Kinsie and Misty. Really interesting, and certainly I'm very excited about the new spectral bands to be able to do that classification better, exactly what Louis was talking about, because we're very interested in looking at changes in habitat, especially forest areas, and being able to classify those different agroforestry and agricultural land use systems within the lens of ecosystem services. It's not new that we use geospatial data for, estimating different ecosystem services, especially doing hydrological modeling, so water quality, water quantity coming out of watersheds. And for that, we need to really kind of identify what are the different land use systems, land cover systems that make part of that watershed. In addition to that, estimating roughly carbon emissions or carbon storage in forest areas and different land use systems. And for that reason, certainly we're interested in those new services that Planet data may be able to render. And other type of services that are becoming much more of interest, and especially for the private sector, is biodiversity conservation, which for that same reason, it's important to understand how forests are being degraded, are being deforested. So disturbance in those areas, and how different, classification of agricultural systems can improve the connectivity of that landscape for the dispersal of wildlife in fragmented agricultural landscapes. So I have a question back to you guys, and that would be, so as an organization that is looking to utilize, the state-of-the-art type of data and satellite images, and in that case, Planet images fall into that scope, how organizations like ours looking to do monitoring and now with more interest for monitoring private sector type of activities, how can we as a nonprofit make Planet images, or use Planet images, or how are you guys looking to make Planet images more affordable for organizations like ours to basically look into monitoring and accountability by for-profit organizations? Over to you.
Well, and I thank you for that, Wendy, and especially for answering questions I already have answers to. So Planet recently rolled out a nonprofit program because of that exact issue. We realize, we're a business, we are publicly traded, and so we have for-profit customers, but at the same time, there's a lot of really good research going on. There's a lot of, occasions that need intervention for, whenever it's not a multi-billion-dollar ag retailer who's looking at their crops, it's researchers looking to make the world more sustainable and the land use there. Let me go ahead and find the link while we ask some more questions, and I'll drop it in and then take a look. It's a great pricing product and package. They've made everything available. They've made it much more for the mindset of research and monitoring and intervention across the world, especially by nonprofits. We're really proud of that program. And like I said, let me grab the link while we have some more conversations so you can take a look at it and see if it fits your needs too.
I'd love to call in just a few questions I've been seeing coming up in the chat. We have some people asking, is anyone using Planet images for things like breeding? Or also people are asking about market tracing and for specific commodities. So if anyone wants to speak to that.
I can definitely speak to utilizing Planet monitoring for breeding purposes. So we do have clients that utilize Planet monitoring for breeding purposes. We have individuals who utilize our high resolution constellation in order to monitor their breeding plots all over the world. Oftentimes, a plant breeder is located in one region and is responsible for multiple global programs. So it's a great way to get cohesive data for all of the plots that you need to be examining. In addition, when we're looking at seed increase scenarios, daily PlanetScope monitoring has been used in order to monitor things like disease and pest infestations that would heavily impact seed yield. So those are two of the scenarios in which PlanetScope monitoring is being used for breeding purposes.
I wanted to ask a follow-up question about the breeding. I mean, this is also a very exciting opportunity. We've been using drones a lot because drones are easier to manage, even flying under the cloud, and also sensor-wise. I mean, a lot of pest and disease monitoring kind of data. We saw if you can see the damage from satellite, it's just too late. I mean, there are already probably widespread damage, and we saw there are some possibility or potential of using hyperspectral sensors can detect those damages in quite early stage. So yeah, I wondered if there are different types of sensor configuration, hyperspectral kind of sensors that you are also planning to mount to the satellite.
Yes, so Planet is launching a hyperspectral constellation here in the near future. And right now we're in the validation phase for many of our use cases and how we're developing our sensors. We're testing out several different sensor variations in order to optimize our data feedback for various use cases. So this is something that we're absolutely looking toward, but it is in process, and it's not something that we have officially settled upon and can publicly present at this time.
I have a follow-up question on that. So in addition to the data access, do you also have plan to provide researchers or users access to some sort of computational platform or integration with some computational platform where we can run our models without needing to download the product, or maybe set up some automation, right? You mentioned about the examples for the for deforestation alert, right? Set up some of those automated model in the system so that we don't need to we can do the analysis almost at the real time as soon as the data becomes available.
This is one of the issues that's really close to my heart. I lived in sub-Saharan Africa for a number of years, and the internet problem is a real problem. If you can't get the data that you need, how are you supposed to do the work that you need to? That is something that we haven't completely fixed. We do have a lot of online platforms for it. But one thing that Planet's rolled out recently as well is we can host data on the Planet Explorer website, which alleviates the issue of having to download it, keep it yourselves. I mean, if you're downloading a lot of data, especially as we're talking about archive over 2017, you'd have to have separate servers. These are giant, they can get so big and so much data is consumed, and there's a cost associated with that. So by hosting the imagery on Planet Explorer, we're attempting to alleviate that. It's all about accessibility, making sure that it's not just people with really good internet connections that can utilize the data. Trying to make that as easy as possible. We also have integrations with different GIS programs. So if you have ArcGIS, you have QGIS, or you're working with Google Earth Engine, we have Planet integrations there, so you can work within those programs that might alleviate the load on your systems as well. I mean, you still have to have the internet connection to get the imagery into those integrations, but then it's there and it's hosted a lot better. So whereas we don't have a perfect answer for that one, it is top of mind and something our teams are really working on, just knowing that the global impact is so important of just how to increase the accessibility. So hosted data on Explorer and our integrations are our answers for now. And then, Planet's offer to anybody that works with us is we'll help you get it. if you're already one of our customers, you're working with us, it's one of those like reach out, and if you need a little extra support because of lacking internet, or maybe you need some ideas, we also have a professional services team that, in my opinion, is filled with some of the most highly qualified engineers and builders when it comes to different dashboards, machine learning algorithms, and they help too. Like Planet doesn't just kind of want to throw data out into the world and say, have fun. We really want to work with people to get to the right solutions and make sure that it wasn't, you know, suffering involved in trying to get it all to work for you. So we're really big on partnership and collaboration.
So there was a market. There's a market-related question. Can we trace market and market segment for specific commodities? Yeah, I don't know if there are some examples or use cases you can think of using Planet data for. Yeah.
Where is that? Let me read that question. I don't think I'm understanding quite right. Can be used to trace market and market segments for specific commodities. Is this more like about supply chain transparency whenever we're looking at different market segments? Would that be what's really, I want to make sure I give you the right information.
Yeah, probably.
Most likely, we'll go that direction. And if we need a follow up, we can always go there too. So whenever it comes to market segmentation, especially when it comes to supply chain analysis, this is something that a lot of the really large CPGs, the consumer produced good organizations, are focusing on, because they're the ones who are out there making the statements that they have a more sustainable supply chain. And a lot of the time, whenever you look at those, it's understanding what you think is happening. But with satellite data, you can look at your raw production, you can see what practices are going to be used. So this goes beyond, you know, the crop identification, moving into practice identification, which is really important for different carbon programs that are out into the world. And it also adds validity to the claims of sustainability, because then you can look at where in the supply chain do you have the biggest problem? What part of that segment is creating the most either pushback, or is it harder to get the evidence for? And using satellite data, you can collect those, you can do change analysis. I work with one customer that harvests sugar beets. And what they do is they put beacons on their trucks and create maps that they then correlate with satellite imagery to make sure what is harvested, what is it harvested, whenever it gets to the piling site to create, to go through the processing for sugar. There's also a lot of waste that could be involved. And so they use satellite data to minimize the amount of waste, because they can organize those harvests and the deliveries in a way that their production plant can still maintain the flow with. So you don't have beets standing out in the yard, hoping and praying that you don't have a freeze or it doesn't get too warm and then that product is damaged. So waste mitigation is one of the big pieces for markets and supply chains, visibility into each stage of it from raw all the way through processed. And then after that, the kind of the food miles and the driving the carbon emissions that are going to come from getting those final products where they need to be, and just really capturing all that in a way that makes it more reportable. You're having, you know, actual data points as opposed to, I feel that things are going well. Now you know. And that's what we've seen satellite data kind of working towards. Oh, okay. So Ralph has added a little bit to this question. So the seed of specific crops used in specific regions, foods made of those crops. Oh, so we do have different customers, and mostly test plots is what we're looking at here, with whenever specific crops are grown for a region, where they're grown, what the market segment's going to be for them, are they being transported, are they being wasted, and a lot more monitoring in that. And so Ralph, I hope I've answered your question, but I might have rambled a little bit.
I would also add.
Oh, yeah, sorry.
I would also add, we do have some partners who do a really good job translating drone data, satellite imagery, and deriving insights based upon potential yield or dry down and things like this, being able to track the perceived yield and amount of recovery for different commodities. So we do have partners that offer additional resources outside of some of our more basic data streamline services.
Yeah, fantastic. Actually, this reminded me of something that we have been just going around. You mentioned sugar beet, a specific kind of commodity. There are specific commodity-based kind of use cases out there. How many satellites do you have now? Like 300 or 400? Like they're large, right?
200 and some change of the doves, and I think we're right around 21 for the SkySats, the high resolution.
Yeah. So would it make sense for us to have like CGIAR? We are like 8,000 scientists, research organization working on many different things in globally, but if there are specific use cases, it makes sense. Does it make sense to have our own satellite or not? I mean, are there pros and cons of launching our satellite? It's becoming kind of, we saw podcasts are launching their satellite. We saw like different universities are launching their satellite. Like, why can't we? Like, so we thought maybe there is a need for us to also have our own satellite that might give us some advantage or something.
Well, I mean, from what I learned, it takes a lot to launch a satellite and keep it in space. So I don't think I'd go down that path unless I absolutely had to. But that's just me. It is really cool. I love seeing them go up there. But one of the best things about Planet satellites is they're small. So like our doves are about the size of a loaf of bread. And lots of information and engineering has gone into creating those. If you want your own satellite, sounds great. Might be a little bit easier to give us a call and we can help you get what you
absolutely.
need. But...
Oh, no, yeah. No, I didn't mean to design and develop something our own. I mean, working with you and design based on our specification and, you know, as you to launch, but yeah, having our own kind of ownership of one of those stuff for our applications.
It's an interesting concept.
Well, that is certainly a fantastic idea. I do have to jump in here because it looks like we're coming to the end of our time here, but certainly, you know, to the stars with all these ideas and use cases for this kind of data. So I'd really just like to thank all of our speakers. Thank you, Misty and Kinsie from Planet. Thank you, Jawoo, Ani, Louis, and Wendy from the CGIAR, and of course, to everyone in the audience. Thank you for venturing out with us. So we're coming to the end of the event here and now, but this event is just the kickoff to our work investigating these ideas for geospatial data innovation. The Accelerate for Impact platform wants to source more ideas from you on how Planet's data and tools can be applied. Access to high-resolution satellite imagery and analytics capabilities, like that powered by Planet, can equip scientists and innovators with valuable insights to improve the efficiency and effectiveness of the research, to better understand the impacts of different interventions, and to support the development of new technologies and solutions, aligning with CGIAR's vision of a food secure future. So share these ideas with colleagues and fellow innovators in your network. We'll send you a follow-up email where you can let us know how else we can innovate using these tools. So on behalf of the Accelerate for Impact platform, thanks again to everyone who joined us live. Our team is already working on our next event. We want to keep informed and engaged with this community, spur new ideas for collaboration by engaging with innovative ventures like Planet and learning from their scaling journey. So thanks everyone, and see you next time.